Alright guys, so again, we've got a parabola whose equation is given to us in standard form. As it looks right now, I don't know much about this parabola. If we could somehow transform it into a vertex form of a parabola, well then it's going to be a lot easier to find its vertex, its axis of symmetry, whether or not it's upward or downward facing, whether or not there's been a vertical stretch or shrink. It'll just be a lot easier for us. So what I notice is, once again, I see this x minus h quantity squared in that vertex form of our parabola. So I need to have a perfect square trinomial somewhere in here. Well, I see 2/3 of one right there. So what I'm going to do is I'm going to rewrite this equation. I'm going to toss this x squared minus 4x into a set of parentheses, and I'm going to leave this extra minus 6 by itself. Well, now we need to actually go ahead and complete this square. And I think we all know how to do that. We've got an x squared minus 4x, and I think we need to add 4. And once again, I just have this minus 6 coming on down, nothing special there. Well, obviously, we've changed this equation by adding that 4 there. Our equation is no longer balanced. Well, to keep it balanced, I think we need to then go ahead and subtract a 4 on this same side of the equation. Together, it's as if we added 0. And so that would maintain our equation. It would stay balanced. So, well, we've gone ahead and we made that perfect trinomial square. This is exactly what we were hoping for. Because now we can write this parabola's equation as y equals x minus 2 quantity squared. And these guys will add to minus 10. All right, check it out. We're in position to go ahead and graph this. We know what the vertex is. The vertex is the point 2 comma negative 10, and our axis of symmetry is the vertical line x equals positive 2. Like I said before, I would very strongly urge you to go ahead and graph that axis of symmetry. I find it very helpful to have there when I'm sketching my parabola's graph. Okay, now where to go from here? Well, we know it's going to be an upward facing parabola, right? We've got a positive 1 times x minus 2 quantity squared, but we don't know exactly what it's going to look like, so we got to find some points. The place I always look to start is with our y-intercept, and here in the standard form of our parabola, that's the easiest way to find our y-intercept. So our y-intercept happens to be negative 6. In this case, we got 1 point. Looks like we got another one for free here by using the axis of symmetry. Still got a pretty good idea of it. I might want another point or two. And in this case, I think our x-intercepts are going to be really helpful. Note that I always want to know what the x-intercepts are, but they're going to be really helpful in this case. So I'm going to use this standard form of the equation, and I'm going to, the vertex form, and I'm going to set y equal to 0. So 0 equals x minus 2 quantity squared minus 10. Alright, so let's add 10 to both sides. Let's go ahead and take the square root of both sides of the equation. So I think we've got plus or minus the square root of 10 equals x minus 2. Let's add 2 to isolate our x. So it appears that the x coordinates of our x-intercepts will be 2 plus the square root of 10 and 2 minus the square root of 10. So this is a lot tougher, right? The square root of 10 is not an easy number. Well, I'm taking a look and I'm thinking, well, 10 is a little bit bigger than 9. So I'm thinking that the square root of 10 is going to be just a bit bigger than 3. So I might say it's around 3 plus. That's just the way I kind of write it, a little bit bigger than 3. So when I'm thinking, all right, where are these x-intercepts going to be? Well, I like to make a point and put it right on the coordinate of 2, and I know it's going to be a little bit more than 3 units to the right, so 1, 2, 3, and a little bit. And I know that we're going to have another point, and it's going to be a little bit more than 3 units to the left, so 1, 2, 3, and a little bit. And so there are our x-intercepts. I think we're pretty much good to go. We're pretty much good to graph. Maybe it would be nice to find one more ordered pair. So I'm going to go ahead and try the ordered pair. Well, what if, well, you know what, I think we're looking pretty good here. We're looking pretty good. I'm not exactly sure what our parabola is doing in this area, so maybe I'll try a 3 or a 1 as an x-coordinate and find out what the corresponding y-coordinate is. So if x were 3, then y would be, well, 3 minus 2 quantity squared minus 10. So that's 1 squared minus 10, 1 minus 10, okay. Excuse me, 1 minus 10. Got a little ahead of myself there. Which is negative 9. So we've got the ordered pair 3 comma negative 9. I just want to be real thorough here. There it is there. We can use the axis of symmetry to get this other point, and we are ready to go ahead and graph. Here she is.